Hello and welcome everyone to the Varsity Tutors StarCourse series, where our theory has always been if it's the shortest day of the year, you better pack it full of as much excitement as possible. And that's why we are thrilled to celebrate the winter solstice, at least here in the Northern Hemisphere, with our friends from Pacific Science Center. We've got Holly Duskin here from PacSci, here to talk us through what the winter solstice is all about. We're going to take a look at the night sky. We're going to talk about the traditions, both culturally and scientifically, that coincide with it, and have a whole lot of fun doing that. Now, a couple of things for you. We want to make sure we keep this really interactive because there's a scientific component and a cultural component. You're part of the culture, so use the chat box to the right of the screen. Holly's going to ask you guys a lot of questions to find out what you know, think, and want to know about the solstice. Answer them there. And if you've got any questions for her, don't hesitate to ask. Throw them all in the chat there. In the last 10 minutes or so, I'll interview Holly with your questions so we can get you some answers. Also, make sure you've got a camera nearby because a couple spots throughout tonight's program, we're going to give everybody an opportunity to take a solstice selfie with some of the coolest spots on Earth and the cosmos to celebrate the solstice. If you upload that to Instagram and tag Pacific Science Center and Varsity Tutors after class, you'll be entered to win a pretty amazing prize package that includes a spot in a Varsity Tutors after school club for when school is back in session in January, and a field trip for your whole class with Pacific Science Center. So make sure you got that camera ready. Be ready to keep it interactive. But since we're going to check out the sky here, I need to turn it over to the star of today's show, Holly from Pacific Science Center.
Hey, everybody. Thank you so much, Brian. Again, my name is Holly, and I'm joining today from Pacific Science Center. We are Big Science Museum over here in Seattle, Washington. And just as Brian said, we've got a really interactive program for you today. So please let me know your thoughts and questions in the chat. And I just wanted to start off by saying happy December solstice to everyone, which is today, December 21st. And in today's program, we are going to learn more about this special day by making some different observations of the sky. We're going to start off in our virtual planetarium, making some observations, and then we're going to be exploring some of those historical and cultural significances of the solstice as well. And get your brains ready because I do have a few trivia quizzes that are going to be spread out throughout our program, so get ready to challenge yourself in that way as well. Now, like I mentioned, we are actually going to jump on over into our virtual planetarium here to help us make some observations of our night sky. And first off, we're just going to get a little familiar with how it works. But the first thing we need to do is actually set the location for our planetarium today. So I would love to have you all share with me in the chat, where are you joining our program from today? Let me know where you're joining from. I'm going to pull up our little map here. You can see we're currently in Seattle. That's where I'm at. Oh my goodness, I'm seeing a lot of people mentioning things like California, New York, Washington. We got folks from Texas and Florida and Illinois. That is all over the place. That's super awesome. So I think I'm going to take us somewhere about in the middle of the continuous United States. You can see our red arrow here. We're going to go right here in the center. And so if you're joining from anywhere in the US, the sky is going to look fairly similar, give or take, to the things we are going to see here from about the center of the US. Now, I'm going to go ahead and fast forward our time into the evening here. And I would love for you all to start sharing with me in the chat. What are some things that you think we might be able to find in the night sky later on tonight in our December solstice night sky? What kind of objects might we be able to see? What kind of things should we be looking for? Awesome. Wow. I'm seeing a lot of really great ideas coming in. Folks are mentioning things like stars, definitely. The moon, maybe some constellations. I see some folks listing some specific constellations they might be hoping to see. I also see some people talking about some planets that we might be able to spot as well. Well, those are all really great ideas and some things we definitely might be able to find in our night sky tonight. Now, a few things that might help us out, though, while we're looking for all those really cool things, it's really helpful to be able to communicate with one another about where we're going to look for those objects in the sky. And one of the words that astronomers, those are people who study outer space, and some stargazers use, is the word horizon. So that's going to be this line right here where it appears that the sky is meeting the Earth. So maybe go ahead and point to that horizon on your screen, kind of get familiar with where that is. Another word that we like to use is the word zenith. It's a super fun word. Definitely recommend trying out loud, saying it out loud to yourself. The zenith is the spot if you were to look straight up in the sky at the very, very top. That's going to be the zenith. You can actually point to the zenith where you are right now. Just look straight up, point right above your head. That is your zenith, right? But if we were outside stargazing right here, this would be our zenith. Now, scientists, taking a look at our sky here, I'm noticing something kind of interesting. I'm seeing a few really big, bright objects really close to the horizon. See if you can take a look. Can you find those 3 big, bright objects that I'm noticing close to the horizon? Did you find them? Nice. Yeah, right here, right where our sun just went down, we've got some special objects here. And I want to zoom in and show us what those are, because these are something special. They're a little bit different than our stars. Like, for example, if we were to take a closer look at this star here, you might notice something going on with the light of this star. What do you notice? Oh, I see some observations in the chat. Yeah, people are saying like it's twinkling or it's flickering, kind of blinking on and off. That's right. The light from stars is coming from so far away that light has to travel through a whole bunch of different gases as it comes through space. It makes this twinkling of the light. But what about these objects, these really bright ones that we were noticing by the horizon? Let's zoom in a little bit. Is it twinkling? Looks like a pretty steady light to me. I wonder what this could be. If you have a guess, you can share with me in the chat, or you can maybe share with someone sitting next to you. What do you think this non-twinkling object is? Let's get a closer look. Anybody recognize this planet? That's right. We're looking at Jupiter here, folks. You can recognize it by these different stripes of gases. If you're wondering what this is one of Jupiter's moons. That's the shadow of its moon passing across the surface of Jupiter here. So that's one of those 3 bright lights. I wonder what these other 2 are. If you've got a guess, you can share with me in the chat. Let's check it out. What is this one? All right. Anybody recognize this planet? Yeah, those rings are a really good giveaway. This is the planet Saturn with its rings made up of different chunks of ice and a little bit of rocks. It's got a bunch of moons orbiting around it as well, just like Jupiter did. And how about that third object? This one looks even bigger and brighter than the rest. And this is actually the brightest object in our whole night sky, except for, of course, our very own moon. This is the planet Venus. So Venus is super, super bright. And just like with our moon, right? Some of the light from the sun, it's only reflecting off of a part of Venus right now. So that's why we can only see a little sliver of it. But, even without a telescope, without getting, using any technical tools, you can take a look later on tonight in our solstice night sky and see if you can find these 3 planets really close to the horizon, right in the place where the sun just set. So I hope you all get a chance to look for those later tonight or over the next few weeks. Now, the horizon and the zenith, those were some helpful words to help us navigating our night sky. But there's something else that might be really helpful for us as we look at the sky. And that actually brings us to our first quiz. Which object in the night sky appears to remain in the same location all night long? Go ahead and share with me your guess in the chat. Do you think it's number 1, the Big Dipper? Number 2, the North Star. Number 3, the moon. Or number 4, the planet Mars. Ooh, I see a lot of votes coming in. Keep them coming. I'll give you a few more seconds here. Now, the reason why we're looking for an object that appears to remain in the same location is that might help us, right? With our navigating, might help us better get our bearings in our night sky. All right, go ahead, finish getting your votes in. We are going to reveal the answer in 3, 2, and 1. It was the North Star. If you got it, go ahead, give yourself a little round of applause there. And let's head back into our planetarium. See if we can find that special North Star. So this is going to be an object that appears to stay in the same place. Here's the problem though, scientists. It's a little tricky to find our North Star. It's not at all the brightest star in the sky. In fact, it's about the 48th or 49th brightest. So instead, we're going to need to maybe use a little astronomy trick to help us find the North Star. We're actually going to look for that other shape that we were just talking about, the Big Dipper, first. And once we find the Big Dipper, we're going to use that to help us find the North Star. So I'm going to start fast forwarding us through time here, and I want you to keep an eye out. See if you can find that shape, the Big Dipper, somewhere in our sky. Once you find it, you can maybe point to it on your screen. Maybe let us know in the chat if you see it. Is it closer to the horizon down here? Is it closer to the zenith up top? All right, I see a lot of scientists saying, I see it, I found it. It's kind of close to the horizon. I just saw it pop up as well. If you haven't found it yet, no worries. We're going to count out these stars. We've got 1, 2, 3, 4, 5, 6, and 7. Now, these 7 big bright stars make up a shape that a lot of people call the Big Dipper, although it does have many different names for different cultures all across the world. So in the country of Turkey, they call this shape the teapot, and in Germany, they call it the wagon. So maybe you can kind of imagine some different shapes made of these 7 big bright stars. And we're going to use these stars to help us find that North Star. So these 2 stars at the very, very end, there are pointer stars. They're going to point us in the right direction. And we're going to go 5 star hops in that direction. What is a star hop, you might ask? Well, we are going to make up the distance of a star hop. We're going to say it's this distance right here between these 2 stars. So actually, go ahead and give it a try right now on your own. See if you can kind of count out across the sky 5 star hops in this direction. See if you land on any particular star. And let's count it out together. Here we go. 1, 2, 3, 4, and 5. Did anybody else get this star? Yeah? Nice. Okay, let's check our work, see if we found the North Star. I'm going to turn on our directions down here. Hey, we've got an N for north. Nice work. This star is also called Polaris, amongst other names. And you know, there's something else special about Polaris. It's actually the end of another shape of stars in the sky called the Little Dipper. It's a little hard to see here, so I think I'm actually going to turn on our constellation lines for us. You can see our Big Dipper over here, part of the constellation Ursa Major, and our Little Dipper here, part of the constellation Ursa Minor. We can turn on our constellation artwork as well, so you can just get a look here of some of the constellations that are going to be up later on tonight in our Solstice Night Sky. Now, there is something really special about this North Star that I wanted to show you before we move on. So I'm going to start fast forwarding through time here. And I would love to hear your observation, scientists. Go ahead, let me know in the chat. What are some things that you notice happening as we fast forward through time? We're going to go all the way through the next day. So you might see the sun come up, but I'm going to leave our constellation pictures turned on so that you can see some patterns that might be happening in our sky. All right. I see some folks noticing, yeah, the stars are moving, they're rotating. I see a lot of people using the word spinning. I'm kind of noticing that as well. They're kind of going in a predictable circle here. Now, what is happening with our North Star, though? What's going on there? All right. Yeah, I see some folks letting me know the North Star is holding still, right? It's staying in one place, and everything else appears as if it's spinning in a big circle all around that North Star. Great observation, scientists. But I have a question for you. Is it actually all these stars out in space that are spinning around? Or is it maybe something else that is doing the spinning? If you have a guess, you can share with someone you're watching with. You can let me know in the chat. What do you think is causing that spinning? All right, I see a lot of folks have figured it out. That's right. It is actually the Earth that is doing the spinning. So you might know our Earth spins on its axis once every 24 hours. That's what gives us day and night. And our Earth is also tipped over a little bit. It's got a tilt to it. And the reason why our North Star stays in the same place is because if you were to imagine a huge arrow shooting out of our North Pole, it just so happens to line up with that star Polaris, the North Star, over 300 light years away in space. So it's actually kind of a bit of an optical illusion that's making it look like all those other stars in space are spinning, when it's actually us here on Earth doing the spinning. And scientists, you can actually test this out at home right now. What you can do is actually pretend your body is the planet Earth. Pretend your nose is the tip of the North Pole. So you're going to want to look up, put your nose at the top. And I want you to pick a spot, the zenith, right above you. Maybe it's a little spot on your ceiling. Imagine that is the North Star way out in space. And then what you can do is while you're keeping your eyes glued up there to that spot on your ceiling, you can do one slow spin in a circle like this. So go ahead, try it out if you'd like to. You can stand on up, look up, pick your spot, spin in one slow circle. See what you notice. And then go ahead and find a seat again before you get too dizzy. All right, did anybody notice that the things in the room you're in kind of look like they were moving? Like maybe there was a table or some chairs or a door. It looked like it was spinning past you. All right, but of course that room wasn't moving. It was actually you, the Earth, that is moving. And that's exactly what's going on with our Earth every day. And that's what's causing our stars to appear as if they're moving in a circle around our North Star. Nice work, scientists. So now that we are a little bit more familiar with our virtual planetarium, and we found a few of the different things that we can see in tonight's night sky, I want to explore a little more about what makes today, the December solstice, so very special. So we've got our next trivia quiz for you. What does the December solstice mark? Is it the start of winter, number one? Number two, the start of summer? Number three, the day when the sun's path is at its southernmost point on Earth? Or number four, all of the above? And I will say this is a little bit of a tricky question. So just do your best. Give me your best guess in the chat. Do you think it's 1, 2, 3, or 4? What is today the December solstice? All right, take about 10 more seconds here to get your answers in. Oh goodness, I'm seeing all kinds of answers coming in for this one. All right, scientists, here is your answer. Here it comes in 3, 2, and 1. Oh, it was number 4, all of the above. I did tell you it was a little bit tricky, but guess what? Because all of these are true, if you picked number 1 or number 2 or number 3, go ahead, give yourself a pat on the back because all of these are correct. Well, how is that possible? Our December solstice today is the start of winter for folks in the northern hemisphere, where I know a lot of us live. In the southern hemisphere, though, it's actually the start of summer today. And for everywhere, no matter where you are on Earth, today is the day where the sun's path in the sky is the furthest south that it goes. So what do we mean by the sun being in the furthest south? Well, we can actually come out of our nighttime. I'm going to take us back to daytime here in Kansas in the middle of the United States. And we're actually going to take a look at our sun throughout the year to help us better understand what we mean by that sun being to the furthest south on today. So we're going to go to sunset on our December solstice. So just a little later. All right, I'm going to stop right there. And I want you to notice, scientists, where is the sun on the horizon? All right, maybe kind of pay attention to these bushes here, or maybe you're noticing the sun is setting by the southwest. And I'll zoom us out a little bit so you can see the south is in this direction over here, and the north is in this direction over here. And what we're going to do is one of my favorite things to do in the planetarium, which is a little bit of time traveling. You can see a 12 here for December. I'm going to fast forward us into January, February, March. I want you to watch what happens to the place where the sun is setting on the horizon. All right, here we go. Here's January. Here's February. And I'm noticing it's not quite sunset yet, right? So I'm also going to bump our time a little bit later in the evening so we can see the sunset point. Here we go to March. Ooh, we really got to get later in the evening. All right, April. Get us back at sunset. Here's our sun. May and June. All right, so here is our sunset on June 21st. Go ahead and share with me in the chat, what did you notice happening to the place where the sun was setting on the horizon? We just went from December all the way forward to June. What did you see? All right, yeah, so folks are saying things like the sun is moving. Some folks are mentioning the west and the north. So the sun started over here towards the southwest, right? And it was moving all the way towards the north in the June solstice. Awesome, great observations. All right, what do you think is going to happen if I keep time traveling some more? If we finish the rest of our year from June all the way till December? So take a look, pay attention to where our sun is, and let's find out. All right, we're going to July. We're going to August. Oh, interesting. I'm also going to have to bring our time a little earlier. Our sunset's happening a little earlier. September. October. Oh gosh, we're going to have to bring our sunset a lot earlier. November. Oh, there's our sunset. And December. Here's our December sunset again. All right, scientists, what'd you notice this time? What direction was that sunset moving on the horizon? Yeah, I see a lot of folks saying like it's going back, it's returning, it's moving back towards the south or the southwest. That is exactly right. So on today, our December solstice, that sunset, no matter where you are on Earth, is going to be setting in the southernmost part of the sky that it gets for the whole year. And this is actually where the word solstice comes from. So sol is an old Latin word meaning sun. And then sistere, again from Latin, means to stand still. So you might notice here for a few days around our December solstice, our sun appears to kind of stay still in the same spot in the south before it switches directions and starts going back to the north. And then same in that June solstice, the sun's going to stand still over here towards the north before it starts moving back towards the south. Pretty cool. Now, even though this is true no matter where you are located on Earth, we also talked about earlier some of those differences, right, between being in the northern hemisphere or the southern hemisphere. So let's see what some of those differences are. I'm going to bring us back to today, December 21st on 2021. And I'm actually going to bring us to maybe sunrise. So let's maybe go to about 7:30 this morning. And let's watch the path of the sun right here in the central United States. So if you want to, you can actually take your finger and kind of trace the path of our sun. I'm going to fast forward through time. So here is our day on the December solstice. And actually, if you know in the chat, right, if we're located in central Kansas right now in the planetarium, are we in the northern hemisphere or the southern hemisphere? Let me know in the chat, maybe an N for northern, an S for southern. What are we watching right now? All right, you all got it. And that's right, we're in the northern hemisphere right now. Ooh, wow, there goes that sun. That was a really quick day. Is the day over already? All right, let's pause here. Remember that path that our sun took across the sky. So this imaginary line that the sun was following, we have a word for that. It's called the ecliptic. And what we're going to do is now we're going to head down to the southern hemisphere and see if we notice any differences. So you can see that big red arrow. We are up in the northern hemisphere. I'm going to take us down to Santiago, Chile. So we're down here in South America in the southern hemisphere. And let's see if we notice any differences. Now I'm going to have to take us back to morning time so we can see the sunrise. And you know what, scientists, we are actually so far south in the southern hemisphere. Instead of facing south, I'm going to turn us around to face north so we can get a little better view of our ecliptic here. So here we go. We're going to do a whole day, the December solstice, but now we're in the southern hemisphere. So maybe take that finger, trace the sun's path, the ecliptic, across the sky. And let me know in the chat if you're noticing anything different. Whoa. What differences do you see between this ecliptic, this path the sun has been taking here in the southern hemisphere, versus the northern hemisphere? Wow, oh my gosh, is this day still going? This is the longest day ever. My goodness. All right, I'm seeing a lot of scientists making some great observations. They were saying the sun is going higher in the sky. Absolutely. I was noticing that too. Our sun was going up higher, right closer to the zenith down here in the southern hemisphere. Whereas when we were in the northern hemisphere, the sun was way down here. It was closer to that horizon. So down here in the southern hemisphere, this is going to be the longest amount of sunlight of any day of the year. Whereas back up in that northern hemisphere, that's going to be the shortest amount of daylight. Now, of course, our sun actually wasn't changing itself during this time, but the sunlight is going to appear different in a different place in the sky, depending on our different locations here on Earth. All right, scientists, I have something else really special for us to do. We did just get to see what the sun is doing on the December solstice in the United States and down in Chile. But I was thinking it might be kind of cool to go to the most extreme place in the northern hemisphere and the most extreme place in the southern hemisphere. Do you have a guess of where I'm talking about? That's right. I'm talking about the North Pole and the South Pole. We are going to go visit those two places. And this is going to be your chance when we get to those places to get your selfie for that contest that Brian was mentioning. So make sure you've got your camera or your phone nearby. Get ready. And go ahead and let me know in the chat, which one do you want to go to first? So you can maybe type in north if you want to go to the North Pole first. Type in south if you want to go to the South Pole. And while you all are voting on that, I'm actually going to switch up our background. So instead of being in a grassy field, I'm going to see if we can go to Ny-Ålesund. This is a German and French Arctic research station. So I've changed our background. Let me go check on our votes over here. Where do folks want to go? Ooh, this is tough. We've got a lot of votes for both. I think there's slightly more for the North Pole. So we're going to go there first. Maybe make a guess in your head of what you think it's going to be like at the North Pole on today, the December solstice. Here we go. All right, here we are. We're at the North Pole. I'm going to fast forward us through time. Let's see what we notice. Let's see if maybe that path of the sun might be different. You can let me know in the chat if you've got any observations. Ooh, I'm seeing a lot of people telling me every direction is south. Yeah, isn't that strange up here at the North Pole, right? There really isn't any more east, west, or north because anywhere you go, you're going to be heading south. Great observation, scientists. Huh, has anybody seen the sunrise yet? It's been quite a long time and no sunrise. So scientists, up here at the North Pole, there is actually no sunrise for 6 whole months. We are in the middle of what we call polar night. And this actually happens not just at the North Pole, but anywhere above what we call the Arctic Circle. So those really, really far north places, they are going to have at least one day up to several months where the sun doesn't come up for at least 24 hours. Pretty cool. I'm going to go ahead and turn off my camera here so that you can get a picture up here at the North Pole. So let me pause our screen up here, looking up here at the night sky in the polar night. Go ahead, get a selfie here if you would like to get your picture at the North Pole. Remember, we're going to be going to the South Pole next. Now, scientists, as you're taking these pictures, just remember after our show, if you tag yourself with Varsity Tutors and with Pacific Science Center, you're going to get entered into a contest to win a free virtual field trip from Pacific Science Center for a group of your choice. So maybe you want to do a virtual field trip with your class, the rest of your classroom. Maybe you want to do it for a birthday party or a family get together. Your choice. Alrighty, my scientists, I'm going to pop back up here and I think we might be ready to go check out the South Pole next. So make a prediction in your head. What do you think it's going to be like on the South Pole on today, the December solstice? If you're watching with someone, you can let them know. You can share your guess in the chat. Oh my goodness, here we are. We can see our research station a lot better here in the South Pole. Very interesting. I'm going to fast forward us through time so we can make some observations. Let me face us back towards our sun over here. And I'll go ahead and turn my camera off as well in case you want to get your picture at the South Pole on the December solstice. Let me know in the chat, what are some things you are noticing or observing? Maybe you're seeing some differences than when we were at the North Pole. Maybe you're noticing some comparisons to when we were in some other places in the Southern Hemisphere. Yeah, a lot of people are pointing out these ends, right? So instead of every direction being south, we've now got every direction pointing north. Oh man, I'm gonna have to turn us all the way over here just to keep up with the sun. Is it just me or has this been a really, really, really long day here on the South Pole? All right, you guessed it. It is never going to be sunset here on the South Pole on our December solstice. In fact, the sun isn't going to set for 3 more months. It's what we call the midnight sun or the polar day. That's when the sun doesn't set for at least 24 hours or longer. And it's happening everywhere past the Antarctic Circle today. So in regions of our Earth that are really far south. All right, I'm going to go ahead and pause here to give everybody one last chance to get their selfie picture at the South Pole at the super cool research station. Remember to tag us after the program to be entered to win. All right, scientists, awesome job. I will pop back up here. Nice work. So scientists, we were able to see that our December solstice, right? It's really different depending on what parts of the world that we're in. But we also talked about that June solstice that happens 6 months further from now, where those experiences are reversed. So here at the South Pole, it's going to be that polar night. And at the North Pole, it will be the midnight sun. Pretty cool. But everything that we've looked at so far are things that we can observe here from our perspective on Earth. But I'm curious, what is happening on a bigger scale that is causing all of these solstice observations that we have been making? That takes us to our next quiz. What causes the solstice, scientists? Go ahead and get your votes in. Is it number 1, Earth's distance from the sun? Is it number 2, the tilt of the Earth? Is it number 3, the temperature here on Earth? Or number 4, Earth's spin on its axis? All right, get your votes in. And let's find out the answer. What is the cause of all these cool observations we have been making? It is number 2, the tilt of the Earth. So just like we mentioned earlier, right, our Earth is actually tilted on its axis about 23.5 degrees. And without this axial tilt, we would have no solstice, we would have no seasons. Because at different times in the Earth's rotation around the sun, different parts of our Earth get more or less sunlight thanks to this very tilt. We can take a look here at this picture. You can see at our December solstice, which is labeled the winter solstice in this diagram. Take a look, that northern hemisphere is tilted away from the sun. So take a look by that end. It's all shadowy and cool. Without that sunlight, it gives us winter conditions here in the northern hemisphere. But look down at that S. That southern hemisphere is tilted towards the sun. This gives it more sunlight and produces summer conditions. Now, after that Earth travels about halfway exactly around the sun, that's going to be our June solstice, labeled the summer solstice on our diagram here. And now the opposite is true. Check out that N. Our northern hemisphere is tilted towards the sun, giving us summer conditions. Southern hemisphere tilted away from the sun, creating those winter conditions. Now, you might have also heard of the equinoxes. Those are just the 2 days that are in between the winter solstice and the summer solstice. So there's one in March and there's one in September. And these are the days when the sun shines down directly on the equator. Equinox comes from a Latin word equal and night. So the day and the night are about the same amount of time on the equinoxes. So that tilt of our Earth is what was causing all those observations we've been able to make so far. But you know what, folks? Observing the night sky is not just about science. It's also about culture and history. And our solstice marks the changing of seasons. So for a lot of folks, this is a time to recognize and celebrate that different change. There's a lot of different holidays and cultural celebrations that fall around this time of year. And a lot of them have historical connections to the December solstice. So let's pick your brains another time here. I'm curious if you can guess which of these festivals does not happen on or near one of the solstices. And I'm going to give you a hint here, scientists. When I say one of the solstices, I mean that could be the December solstice or the June solstice. So which of these is not happening near the solstice? Is it the Scandinavian festival of Yule? Is it the festival of Jani, celebrated in Latvia? Or is it the Moon Festival, celebrated across Eastern Asia? Or number 4, all of the above? Let me know your guess in the chat. Which one is not near a solstice? Let's find out. It was the Moon Festival. So that one's not near the solstices, but the other 2 are. And we're actually going to explore some of these different holidays together to learn a little bit more about them. So we're going to start with that Yule festival that I mentioned. It's been celebrated for thousands of years by Germanic people in Northern Europe. It was marked by a really great winter feast, toasting to the Norse god Odin. So this took place at the December solstice around this time of year. And a Yule means a large log or even sometimes a whole tree that folks would burn on a big bonfire to celebrate for many days. Now, you might have also noticed a picture pop up over here of mistletoe and holly. So those were special plants that were put around people's homes, believed to bring protection and health and fertility. Here they are right here. And you might recognize some of these ancient traditions because some of these have been kind of adopted into the celebration of Christmas. Now, in modern times, the word Yuletide usually is synonymous with Christmas, but there are still some groups that celebrate the non-Christmas version of Yule as well. All right, I wanted to check out another really cool holiday. This one wasn't in our quiz, but this one is really awesome. It's called Nowruz. It's celebrated on the March equinox. So that equinox day that we just learned about, it means new day. It marks the first day of spring. It's known as the Persian New Year. So it's celebrated traditionally in Iran and throughout the whole Middle East by over 300 million people worldwide. So it promotes peace, reconciliation, and like renewal with nature, right? In springtime. So people often spend time outside in nature, gather with family, and have special feasts like the one you just saw with some really symbolic foods. All right, next up, this one was on our quiz. This is Johnny, a holiday celebrated on the summer solstice in June, and it's celebrated in the country of Latvia, which will pop up on our map here in just a second. It's been celebrated for over hundreds of years as a festival after the sowing of crops in the spring, but before that fall harvest. And people celebrate with homemade cheese, which sounds super tasty to me. Also some bonfires like you see here, singing songs and picking flowers. There's also a tradition to stay up all night long. I don't know if I would make it awake that whole time. Sounds pretty fun though. All right, and the last one I wanted to talk about is that moon festival, also called the Mid-Autumn Festival. So this is a really important holiday in China, Korea, and other Asian countries. It's been celebrated for over 3,000 years. So this one takes place usually near that autumn equinox in September. It actually follows the lunar calendar, though, so a little bit different calendar than we use, but it does usually happen around that fall equinox. People celebrate by getting together with their families, doing some moon gazing, these lantern parades that you see here, and eating moon cakes. So these traditional pastries made of lotus bean paste. Very fun. And scientists, I am wondering if any of you have a tradition that you celebrate in the wintertime. So go ahead and share with me in the chat. Is there maybe certain holidays or festivals or just certain activities that you normally do around this time of year? Maybe it's something that you've already celebrated in the last couple of weeks. Maybe it's something that you are anticipating celebrating coming up in the future, right? So a lot of holidays and traditions that happen around these special solstices and equinox days. Oh, I see a lot of folks talking about some holidays. Maybe folks are looking forward to New Year's, Christmas, Kwanzaa. Some folks have recently celebrated Hanukkah a couple weeks back. Some awesome traditions are coming in. So a lot of people say that they go ice skating every year. They go skiing or snowboarding. Maybe people give certain gifts to one another, have certain decorations or clothing, or eat special food around this time of year. So that's really special. Thanks so much for sharing that with me. Now, scientists, not only have these solstices influenced our culture and our holidays, but they've also influenced some really famous structures all across the world. And I'm wondering if you can guess which of these structures was designed to be aligned with the solstice. Is it number 1, the Eiffel Tower? Number 2, the Great Wall of China? Number 3, Stonehenge, or number 4, all of the above? Which one is designed to be aligned with the solstice? And it could be either the December or the June solstice, or both. All right, get those guesses in. Ooh, I think a lot of people are getting this one. I see a lot of threes coming in. Nice job. It is indeed Stonehenge. So we're actually going to explore a little bit about Stonehenge and some of the other structures that have been designed over time to align with the solstice. Now we're going to start with some of the oldest and work our way to some more recent structures. So go ahead, take a look at Stonehenge here. And let me know in the chat, what are maybe some things that you notice or observe about this structure? And for those of you that don't know, this structure is over in the United Kingdom, and it is pretty old. It's about 5,000 years old, but it was built over a really long period of time. So in about 3000 BC, it was started as a spiritual burial site. And then several hundred years later, these rock structures started to get added, but it likely took hundreds of years for all of these rocks to fully be built up. So it was worked on by several different groups of people over the centuries. Yeah, I see a lot of people observing that it looks old. So you are absolutely accurate there. A lot of people are noticing a lot of the rocks have fallen down, right? Which makes sense. If you've been standing for 5,000 years, you're probably going to get pretty tired, get knocked on down some of them. But what is so special about this? How does it align with the solstice? Well, we can actually take a look here at Stonehenge on our December solstice. So today at sunset, the sun is going to pass right through those special stones there called the trilithon. So that's the two vertical stones and the one horizontal stone across the top. And a really similar thing happens on the June solstice, but at sunrise. So we don't know exactly who built Stonehenge or what all it was used for, but we do know that it seems to align with this astronomical calendar of the solstices. Pretty cool. All right, we're going to go check out another structure that is about this almost the same age. These were built really long time ago, but this one is here in North America in current day Wyoming state. So again, go ahead and share with me, take a look at this structure. Let me know your observations in the chat. Now, this structure was built by early Plains Indians, and it's called the Bighorn Medicine Wheel. And there's over 100 of these different medicine wheel structures scattered all across what's now the United States and Canada. And the oldest ones are about 5,000 years old, about the same age as Stonehenge. So even 5,000 years ago, people were really paying attention to those patterns of the solstice in the sky. All right, so people are noticing, yeah, this one also looks old. It's also made of rock. Good observation, right? So, we obviously didn't have plastics or other ways to produce things made of different materials. So a lot of these old structures are made of rock, just like Stonehenge was. And people are noticing that it's in a circular shape. And then there's kind of some lines going through as well. Exactly. So those lines are called spokes. And there's actually 28 of those spokes. Does anybody have a guess? Why 28? And I'll give you a hint. It has something else to do with another object we can observe in our night sky that has to do with the number 28. Ringing a bell for anyone? All right, it has to do with our moon. So the lunar cycle, our moon goes through a cycle every 28 days. So 28 was a really important number to this group of Native people and a lot of different groups around the world. So these 28 spokes here, some of them signify different things. So if we take a look at this picture here, it kind of shows us some dotted lines where if you stand at one of the piles of rocks and you look along one of those spokes, it actually lines up perfectly with where the sunrise appears on the horizon on the June solstice. Another pile of rocks and another of those spokes shows you where the sun sets on the June solstice. So just like we were looking earlier, right? The location of the sunset on the horizon is where these things line up with. Some of the other lines show you where different stars are going to be rising on the horizon as well. Why do you think that people 5,000 years ago wanted to track the solstice? Let me know your ideas in the chat. Why might this have been important for people to take note of these things, to build an entire structure to help them know these things? Yeah, that's exactly right. You all are hitting it spot on, right? They didn't have any clocks back then. They didn't have a written calendar. So paying attention to these different patterns happening in the sky and on our Earth were really, really helpful for planning when to arrive, when to leave certain locations, for planning of the hunting and gathering of certain plants and animals, and they use them to time important ceremonies. So the tribal associations with this area of Bighorn Medicine Wheel include the Crow tribe, Shoshone tribe, Cheyenne tribes, among many others. An oral tradition describes this medicine wheel area as a Sundance lodge. So it was a place of ceremonial importance. And I've got a picture here of our Crow tribe from 2020. So this isn't at Bighorn Medicine Wheel, but it is to show just that these tribes are still here living in this area, and they're still celebrating. They have an annual fair that they do every year as well in some neighboring states. So this example of indigenous astronomy shows us the importance, right, of those different connections between Earth and sky, and shows us Native people's worldview about how things in the sky and things here on Earth were really interconnected with one another. All right, scientists, I'm going to show us one last structure here, and this one is quite modern. So this is called the Sunstones 2. It's located at the Lawrence Hall of Science in Berkeley, California. Ooh, I'm seeing some folks in the chat telling me they've actually been to this place. So I know a lot of you live in California. Maybe you have visited here before. That is super cool. So this was built in 1979, which seems pretty recent compared to some of those other structures that we saw, right? Only 42 years ago. But it's a really cool granite sculpture, and it was built by an astronomer and also a sculpture artist that worked together. So that really tall piece in the middle, it lines up in a line from east to west. And the little slit in the middle shows where the sun sets actually on the March and September equinoxes. And then there's some other components as well that kind of line up with different events that happen during the solstice or during the equinox. So even in modern times, right, the solstice and other patterns in our sky are inspiring people to create buildings and sculptures that relate to these patterns. So it's pretty cool. All right, for my closing question, I just want to know for fun in the chat, which of these structures would you most want to visit? Would you want to visit the Sunstones, the Medicine Wheel, or Stonehenge? Maybe let me know in the chat which one you would most want to visit. And with that, I'm going to wrap us up so that we have a couple last minutes for any questions that are coming in. But thank you so much, everybody, for joining me today and for learning a little bit more about our Solstice Night Sky. I hope you all get a chance to celebrate today in whatever way you would like.
Thank you so much, Holly. Thanks to all of you out there. Chat was rocking tonight. I know we saw a lot of people sharing this with friends. Should make sure everyone knows this was recorded. So if you shared with a friend who hasn't gotten here yet, that's okay. They can still get here and still the solstice for a few more hours, though, that you mentioned celebrate the way we'd like. I'd love to go see that at Stonehenge, but I think the sun is already down in England. So next year, if anybody else wants to join, we'll try to make it happen. So hopefully everybody got those selfies like Holly mentioned. If you get those up on Instagram, we'll have the official handles up on a slide here in just a second. You can tag Varsity Tutors Pacific Science Center, and you'll be entered to win a field trip for your whole class or whatever group you want with PacSci, and a spot in an after-school club with Varsity Tutors. So all kinds of exciting learning to be happening, which leads me to my first and probably favorite of all these questions was, and this is verbatim quote, how do you know all this, Holly?
Oh my goodness. Well, I feel super fortunate because I get to work at a science center. So it is my job to learn about all this really fun science stuff and then figure out ways to teach it to people in ways that are fun and make sense for everybody. So I do get paid to do this. It is super awesome. But yeah, I learned actually a lot of new things about the solstice in doing this research, and I really enjoyed, visiting different websites, reading some books, listening to some awesome podcasts, and I am always just really curious and paying attention to any of those times when I can learn just a little bit more about astronomy and all the other different kinds of science.
Awesome. I think a cool takeaway there is that if you are curious and love learning about all these kind of things, there are jobs out there for you and all kinds of amazing places like Pacific Science Center, Varsity Tutors, and others who want to teach you these things. So definitely take advantage. If we can go back in and keep your questions coming, everybody, there are some great ones. We're a little bit over time right now. We'll go a few more minutes to make sure we get some answers. Really early on, we're taking a look at the night sky from mid Kansas, wherever we were. Mm-hmm. Venus looked amazingly bright, but when we zoomed in, only a little bit of it was getting any sun. Can you tell us how can it look so bright from far away, but when you get up close to it, it actually looks pretty dark and almost like a crescent moon kind of a thing that we would see here?
Yeah, let's maybe zip on back over there and I can pop us back into our planetarium too, and we can take a look. I've still got my Arctic landscape up, but we'll head on over. Yeah, so that is a really good question. And it's kind of like how our moon, right? It can, it sometimes only is showing us part of that reflection of that sunlight, but it's still going to be pretty bright to us here on Earth. And some of that could have to do with like the surface of Venus and what is reflecting off of it. So I happen to know that Venus is covered in a whole bunch of really, really thick gases. So I don't actually know for sure, but I'm wondering if maybe it has to do with that atmosphere and those different gases on Venus that just reflect or bounce that light from the sun really, really strongly into our eyes right here on Earth, right? So just like our moon all the other planets, they're kind of like little mirrors that are just reflecting that sunlight towards us. But some surfaces are going to be more reflective than others. So that's one of my best guesses for why, even if it's only shining a little bit on Venus there, it's still going to appear really bright to us here on Earth. Great question.
Yeah, that's fantastic. Thanks to everybody for asking all those. While you're back in the planetarium software, a lot of questions about what software you're using and can any of us at home access that?
Yeah, absolutely. So glad you asked. So this is called Stellarium. So if you want to use this software at home, you absolutely can. You can visit stellarium.org and there's a web browser version. I'm using the downloaded version, but both of them are pretty cool. It is free, so you are welcome to use it and explore around. And I hope you got a little bit of a chance to kind of see a little behind the scenes as well. So maybe you noticed me toggling over here to change the location or change the date and time or change the landscape of where we were. So those are some really cool settings you can check out if you're going to explore this. Maybe see what the night sky might look like on the December solstice in some other places all across the world. So I definitely encourage you to check it out.
Thank you. I remember when you told me about Stellarium a while ago, and I have it. It is so cool to be able to play around with. So everybody out there, you can turn your computer into a planetarium if you want to. Hey, a lot of questions about, so we know that it's the tilt of the Earth on its axis that creates the seasons like these. People wanted to know, though, does the distance from the sun matter at all? I think a lot of people were saying we have an elliptical orbit. We're not always the same distance.
Yeah.
Does that matter at all for, the seasons, for how warm it is, for our weather? Or is it really just the tilt of the Earth?
Yeah, so that is a really good point. I'm glad people brought that up. So it is true that our Earth doesn't orbit in a perfect circle. So there is times of the year where our Earth is slightly closer to the sun, but it's such a small difference that it does not make nearly as big of a difference as that tilt. So that tilt is really what is placing the northern hemisphere or southern hemisphere. It's not about distance, just about the angle and how long that sunlight is shining on those places, right? So when we've got a lot of sunlight for months and months and months at a time, that is what is going to create those warmer temperatures and give us those spring and summertime conditions. So yes, it is true. We do get slightly closer, but it's just not making a very big significant difference in the bigger scheme of things. Thanks for bringing that up.
Oh, of course. Yeah, that's fascinating to know about. Is that tilt that makes the difference, which leads to another one of my favorites. A lot of people had, do other planets or do all planets, sorry, planets isn't an word. Do all planets or do other planets have solstices? Because they're tilted, do they all have seasons, or is that something special to us on Earth?
Ooh, that is a really good question. I definitely do not know the answer for all the planets. But I know one of the planets, I want to say it's Uranus, but don't quote me on that. Instead of orbiting like this, it's actually like tipped over completely on its side and spinning. So I don't even know what the solstice would be like on that planet. But yeah, that's a really good question. And I know that is something that planetary scientists are looking for actually in exoplanets. So planets that are not in our solar system, but that are orbiting distant stars is, hey, if there is a planet that has that axial tilt, that actually might be a sign that it could be more likely to produce life, because we know that these seasons have been really successful in helping to produce life here on Earth. So definitely something really interesting to look out for on other planets in our solar system and around other stars as well.
Awesome. Well, hey, thanks so much, Holly. This was fantastic. Great to know that we are among those fortunate planets that get a solstice to celebrate. We get two of them, although I think we celebrate this one a little bit more, that we have seasons, and that we have Pacific Science Center on our planet to be able to celebrate the solstice with us. One last question I think a lot of people are asking, hey, can you spell the name of Stellarium? It's stellar, right? Stellarium.
Yeah.
So
Stellarium. So stellar and then IUM at the end and then .org.
Perfect. Well, hopefully everybody gets a chance to check that out. Great way to celebrate the solstice. So is spending time with Holly and the folks at PacSci. So huge thanks to all of you for joining us the way that you did. And we promised on the way out we'll have those official handles. So we put those up here so you guys know exactly who to tag to be able to win that spot in an after school club with Varsity Tutors and that field trip with PacSci. Holly, thanks so much. Hopefully we'll see you back here pretty soon. And everybody else here, same thing. Enjoy celebrating the solstice and your other holidays, and we'll see everybody back here soon.
Thanks, everybody. Happy solstice.